Hi there, welcome to Math 60. We are into Chapter 2, Section 2.1. This is all about solving multi-step linear equations. This is a fundamental skill, solving some type of equation that takes more than one step. So this is one of the most important sections that will support you in this class and in other math classes and in lots of other disciplines moving on. So this is definitely a section to focus on. So let me start with an example. We want to solve 3x minus 4 equals 14. And when I say solve 3x minus 4 minus 14, what I mean is find the x value that makes this equation true. We've done this a little bit. We actually did it in earlier videos. In fact, the video I just recorded, we did this, but now I'm going to lay out the steps a little bit more carefully. So when solving an equation, step one is usually simplify both sides of the equation. In this case, 3x minus 4, that's pretty simple. Don't really have to do anything with that. And 14, that's almost as simple as it gets, so I don't have to do anything there. But I will do an example where you have to simplify first. Then we want to separate the variables and the numbers on either side of the equal sign. So here I have 3x minus 4 equals 14. I've got numbers on both sides. I've got the minus 4 and the 14. I also have the 3, but we're going to deal with that in a minute. So just as we did in the 1.7 video, we're going to add 4 to both sides. And that minus 4 and the 4 is going to cancel, leaving us 3x equals 18. Now all we have on the left are x's. There are 3 of them, but they're all x's. There are no other terms that aren't x's. And then on the right side, we have 18. That allows us to do step 3. Your book calls clearing the coefficient. This multiple, this 3 right here is called a coefficient. Clear the coefficient. I like to say isolate the variable. These really mean the same thing. In this case, we're going to isolate the variable by saying if 3x equals 18, I can divide both by 3. And that gives me, I'm running out of space here. That gives me x equals 6. And now I have a good reason to believe that 6 is the number that makes my original equation true. We're not quite done. Sometimes you're a busy person and you stop there, but when you have time, you want to check your answers, check your solutions in the original equation. So we're going to take that 6 and we're going to put it right into my original equation. And we're just going to check step by step. That's 18 minus 4. 18 minus 4 is 14. It is correct. And now that we've checked it, we can restate the solutions that you have confirmed are correct. X equals 6. And that's the process for solving a multi-step linear equation. It's called a multi-step because first we had to get rid of the 4, and then we had to get rid of the 3. So it was 2 steps. And this one is a 2-step equation, but you can have more than 2-step equations sometimes. And keeping track of your work and keeping track of your steps is a very important part of this process. So let's look at another example. Let's do 3 times negative x plus 2 plus, let's say 5x equals, let's say 30. All right, I just came up with this. I hope it works well. I'm feeling pretty confident. So step one is, let's simplify this, right? I have something trapped into parentheses, and I have x's that aren't all combined together. So simplify by distributing, I'll rewrite it so you can have a clear one at the top. Distribute that distribute the 3 across the parentheses. Since it's addition, I can do that. And I get minus 3x plus 6 plus 5x equals 30. And now I'm going to combine like terms, minus 3x and 5x. If I combine them, I get positive 2x plus 6 equals 30. And now we're back to something like similar to the previous question, where first we separate the numbers and the variable by subtracting the 6. And then we clear the coefficient by dividing by 2. And we get x equals 12. So let's check our solution. You should always check it in the very original, because you never know as you're moving through if you make a little mistake. And if I make a mistake here and I check it here and it works here, but it doesn't work there, I don't have the right solution. All right, so now I'm going to check. I'm going to take x equals 12 and I'm going to put it into my original expression. I'll do PEMDAS here. Minus 2 plus 12 is minus 10. 5 times 12 is 60. 3 times negative 10 is 30, plus 60 equals 30. Yep, that's what I expected. So it's correct. So my answer is x equals 12. That's the process. We get a step 0 if we start with an application, if we start with modeling. So I'm going to use an example for an earlier video because I've already thought about it. I have 20 apples every other day. I eat 3 apples. How many do I have on the, let's say, 3rd day? All right, so step 0 is build a symbolic representation of the math question. And we said, let's see, we had our formula, which is 20 minus 3 over 2x. X is the number of days, and I want to have, oh, I phrased this question wrong. Instead of how many do I have on the 3rd day, I'm going to ask, when do I have 8 apples? There we go. So there's the number of apples on any given day, and I want to know when that number is 8. So step 0 is build a symbolic relationship. Step 1 is maybe simplify, but there's not a lot of simplification to do here because everything's all collected already. So we can jump to step 2 and subtract 20 from both sides. And that leaves us with negative 3 halves x equals, that's negative 12. And the 3rd step is to clear the coefficient. And remember, the reciprocal will always clear the coefficient. So if I have -3/2 here, then I want to multiply by -2/3. That's going to clear that part there, leaving me x. That's a -12. And a calculator can help if we need to, but that's all right. That should be it should be 4. -2/3 times -12 is 8. So now we want to check that answer. So we're going to take 20 minus 3/2 times 8, which is 20 minus 3 times 8 is 24, divided by 2, which is 20 minus 12, which is 8 apples. When the day is 8, the apples is also 8. And so our last step is a little different because we started with a modeling question. We're going to write a sentence. We're going to go back to the verbal representation to answer our questions. On day 8, I have 8 apples left. All right, thanks for watching. That ends this video, and I'll see you for the next one. Thanks for watching.